let's try this problem, and it's a beautifully created problem based on recursion. So the question is, Sn is defined as 0 to pi sine n dx. We have to find limit n tends to infinity n times Sn plus 1, where n belongs to natural number. So this is not a completely new problem, because in this kind of problem we need to first relate Sn with its neighbors. So we have Sn plus 1, and the similar problem already appeared in ISI, CMI and JEE Advanced repeatedly. So I hope you already know how to start the problem. So somehow I need to relate Sn with their neighbors, and in doing so the obvious technique is to use integration by parts. So I'll use 0 to pi sine x to the power n minus 1 dx, and now we can leave sine x to the power n minus 1, integrate sine x, that gives minus cos x, evaluated from 0 to pi, minus integration of 0 to pi, differentiation of sine x n minus 1, n minus 1, sine x n minus 2, sine x ka derivative is cos x, and that is minus cos x, so that becomes cos square x dx. Now at 0 sine goes, and at pi sine goes, so this simply evaluates to 0. So I'm left with n minus 1 times 0 to pi sine x to the power n minus 2. Interestingly, cos square x can be broken as 1 minus sine square x dx, which gives n minus 1 times 0 to pi sine x to the power n minus 2 dx minus 0 to pi sine x to the power n dx. And based on the definition of Sn, this turns out to be Sn minus 2 minus Sn. So now we got a relation between Sn and its neighbors. So it can be written as Sn minus, so plus n minus 1 times Sn equals n minus 1 Sn minus 2, which gives you n times Sn equals n minus 1 Sn minus 2. Since n is a natural number, so clearly it's not 0, hence I can divide by n, and that gives Sn equals n minus 1 by n times Sn minus 2. In fact, this is a route by which even Wally's formula is proven, 0 to pi by 2, if you remember. So with this interesting result, now we are ready to tackle the problem. So Sn plus 1 will be given as n plus 1 minus n by n plus 1 times Sn plus 1 minus 2, which goes to n over n plus 1 times Sn minus 1. So now, equipped with these tools, I am ready to hit this problem. Equipped with this tool of Sn plus 1, we can define Qn equals n times Sn plus 1, because we need to find limit n tends to infinity of this expression, right? So we can clearly see Q1 is going to be 1 times S1 and S2, and S1 value is very simple, because 0 to pi sin x dx, and that is going to give me 2. S2 value is 0 to pi sin square x dx, and that will give you pi over 2. So it's quite easy to check. So the value that we are getting for Q1 is simply pi. Now I can find Qn as n times of Sn, and Sn plus 1 can be written as n by n plus 1 Sn minus 1. And that very nicely can be manipulated by n square by n square minus 1 times n minus 1 Sn minus 1 Sn. The reason of inviting n minus 1 is we can clearly see Qn minus 1 will give birth to n minus 1 Sn minus 1 Sn. And this expression can be written as simply Qn minus 1. Hence I have a recursion. Qn is n times n by n plus 1 times n minus 1 times Qn minus 1. Right? So now we can find again on qn minus 1 we can relate with qn minus 2 with the same recursion by reiterating it again and again. So that gives qn equals q1 times product of qk by qk minus 1, and k is running from 2 to n. And this indeed is q1 times that ratio is product of k equals 2 to n, k times k divided by k minus 1 times k plus 1. And this is just a telescopic series because we can see by putting 2 we'll get 2 by 1 into 2 by 3. Next term is q1 times this one. Put k equals 3, so we have 3 by 2 into 3 by 4. So you can see how this bracket gets killed off. Put 4, so we'll have 4 by 3 into 4 by 5 and so on and so forth. So we'll have n by n minus 1 times n by n plus 1. And we can easily see the cancellation because 2 by 3 is killing 3 by 2, 3 by 4 is killing 4 by 3. So if I'll take 3 brackets, the first of first and last of last remains. So that shows everything will get killed and the last of our n by n plus 1 and 2 by 1 will remain, which gives q1 times 2n by 1 times n plus 1. And now we know qn value is already pi, so we have pi into 2n, which gives 2n pi. So plugging q1 as pi, 2n pi divided by n plus 1. And that's really cool because qn we got as 2n pi by n plus 1. So according to the question, we want limit n tends to infinity q of n, and that simply gives n times 2 pi by n times 1 plus 1 by n gets cancelled. N tends to infinity, this will tends to 0, so we have 2 pi by 1, hence answer for this beautiful problem is 2 pi. So I hope you have enjoyed, and what's important here, the first crucial step was to create a recurrence and relate Sn with their immediate neighbors. Once we are done with that, we have created another recurrence with ns and Sn plus 1, and that becomes a telescopic product. Everything got settled nicely and we are left with 2 pi as the answer. If you like the videos, please do comment and subscribe to my channel if you are new. Keep enjoying quality content for free. Thank you. Have a good day.